Welcome back to the deep dive. We've been on this journey exploring the OEIS and all its fascinating sequences.
Yeah.
And today...
It's been pretty fun.
Yeah, it has.
You
Today
know?
we're going to take a closer look at
Definitely.
a sequence that is A000132.
Yeah, this one's really cool, and it might seem familiar at first glance because it deals with sums of squares.
Okay.
Specifically, A000132 tells us how many ways we can express an integer as the sum of 5 squares.
Okay, so as number theory students,
Right.
we've all seen sums of squares.
Exactly.
But I have a feeling there's more to this sequence than meets the eye.
Oh, absolutely. There's always more than meets the eye, right?
Right.
So why don't we start with a simple example just to kind of illustrate how this sequence works.
Okay.
Let's take the number 4.
Okay.
You can express it as 2 squared plus a 0 squared plus 0 squared plus 0 squared.
Right.
But that's just one representation.
Okay.
There are actually 80 different ways to write 4 as the sum of 5 squares.
Wow. 80. That's a lot. I would have thought there would be far fewer.
It is a lot, right? It's surprising. And
Yeah.
as we go to higher numbers, the sequence gets even more interesting.
Okay, so...
But before we kind of delve deeper,
Yeah.
I want to highlight like a curious pattern in the units digit of the numbers in this sequence.
Okay.
They always end in either a 2 or a 0.
That's interesting. Is there a reason for that?
There is. It all comes down to the properties of squares.
Okay.
When we look at their remainders after dividing by 5.
Okay.
So think about it. The possible remainders when a square is divided by 5 are only 0, 1, and 4.
Right.
Now, to get a sum that leaves a remainder of 2 when divided by 5, we need specific combinations of those remainders from our 5 squares.
Okay.
And it turns out that only happens when the original number itself is 5 times a square.
Oh, wow. So that simple pattern in the units digit
Right.
actually tells us something deeper about the
Exactly.
structure of the squares and their combinations.
Exactly.
Okay, well, how do we actually calculate these numbers?
Well, that's a good question.
Like, are there formulas?
There are.
Okay.
So generating functions are a really powerful tool in number theory.
Okay.
And A000132 has a particularly elegant one.
Okay.
It's sum xk2,
Whoa.
which may seem a bit intimidating at first glance, but it essentially encodes the entire sequence into a single expression.
Okay, so as number theory students, we've seen generating functions.
Right.
Can you just give me a little
Oh, yeah, absolutely.
idea of how this one works?
Absolutely. So imagine expanding this expression.
Okay.
Each term in the expansion would correspond to a particular way to choose 5 squares.
Right.
And the coefficient of that term would tell us how many ways to get a specific sum.
Oh, okay.
It's like a compact way to represent the entire sequence and analyze its properties.
Okay, so it's a way to kind of
Yeah, it's a shorthand.
shorthand it, yeah.
Exactly.
But are there more explicit formulas for this?
There are indeed. So Seiichi Maniyama came up with a recursive formula which allows you to calculate terms based on the values of previous terms.
Okay.
And Daniel Sutil found a formula that directly relates A000132 to A000118,
Okay.
which is the sequence for the number of ways to write an integer as the sum of 4 squares.
Oh, okay.
So if you know how to calculate the terms of A000118, you can use that to find the terms of A000132.
Wow, so we have all these different ways to approach it, generating functions, recursive formulas,
Right.
connections to other sequences.
Exactly.
So A000132, it seems like it's more than just a sequence?
Yeah, it's really fascinating. What's truly fascinating is that A000132 isn't just a sequence, it's also the theta series of the lattice Z.
Whoa. Okay, hold on.
Yeah, so
Those series and lattices.
this connection opens up a whole new world of quadratic forms and modular forms, which are fundamental concepts in number theory.
Those sound like pretty advanced topics.
They are.
Can you kind of break it down for me a little bit?
Oh, yeah, absolutely.
Like, what is a theta series?
So think of a lattice as a regular grid of points in space.
Okay.
And Z specifically is a 5-dimensional lattice.
Okay.
So the theta series associated with this lattice essentially counts how many lattice points are a certain distance from the origin.
Oh, wow.
And that's directly related to how many ways we can express a number as the sum of 5 squares.
Okay, so the theta series is like this bridge
It is a bridge.
between the geometry of the lattices and the arithmetic
Exactly.
of the sums of squares.
Precisely. And that's where quadratic forms come in.
Okay.
The expression x orota plus x per orota plus x orota plus x horota that we're dealing with when we talk about sums of 5 squares is a specific type of quadratic form.
Okay.
And A000132 tells us how many solutions this equation has for different values of n.
Oh, wow. This is starting to paint a much much more complex picture than just, like I said, a sequence of numbers.
Right. It's beautiful though, right?
Yeah,
Uh,
so we're starting to see connections to these like really deep mathematical ideas, lattices, theta series,
yeah.
quadratic forms, and you mentioned modular forms earlier.
Right. Modular forms are fascinating.
How do those come into play?
So modular forms are functions with special symmetry properties that are related to transformations of the complex plane. And it turns out that many theta series, including the one for Zeur, exhibit these properties, making them a special type of modular form.
Oh, so we're connecting A000132 to theta series,
Right.
which connects it to modular forms.
Exactly.
It's a beautiful chain.
Yeah, and modular forms, we kind of touched on them earlier, but what's so special about them?
Modular forms have deep connections to various areas of mathematics and even physics.
Wow.
They pop up in number theory, algebraic geometry, string theory, and even cryptography.
Wow, so they're like,
They're everywhere.
yeah, they're all over the place.
Exactly.
And the fact that A000132 is connected to these objects,
Right.
it just means that it's a really mathematically rich sequence.
It suggests that there might be more to it than we initially thought.
It sounds like we've only just scratched the surface of this sequence.
I think so.
From simple counting to generating functions, and now to lattices, theta series, and modular forms. It's amazing how deep you can go.
A00132 seems to be a gateway to a whole world of deeper mathematical exploration.
Absolutely. And in the next part of our deep dive, we'll delve even deeper into these connections and explore how A000132 relates to other intriguing mathematical concepts.
Welcome back to our deep dive into AI00132. In the last part, we started uncovering some pretty interesting connections between this sequence and some surprisingly advanced concepts.
Yeah, like lattices and theta series.
Right, and even modular forms.
Oh, those are really cool.
Yeah, they are. But
We've only just begun to explore this sequence.
it's amazing how a sequence that seems to just be about counting the ways to add 5 squares
Right.
can lead to all these deeper mathematical concepts.
Exactly. It highlights how interconnected math is.
Right, and it makes me wonder if there's like a way to visually represent A000132,
Oh, that's a great question.
like a graph or something.
Yeah, well, visualizing a five-dimensional lattice might be a bit of a stretch.
Yeah,
But we can definitely represent A000132 graphically because at its core, it is a sequence of numbers.
right.
And the OEIS entry actually includes a graph that plots these numbers,
Oh, okay.
which allows us to see patterns and trends and stuff.
So even though we're dealing with these abstract concepts like lattices and beta series,
Yeah,
we can still ground our understanding
exactly.
in something visual.
Sometimes those visualizations can help spark new insights. Like,
Okay.
for example, by looking at the graph of A000132,
Yeah,
we might notice how quickly the values grow or if there are any like repeating patterns.
okay.
And these observations could suggest new relationships or properties to explore.
So it's always helpful to combine abstract reasoning
Right.
with some visual aids.
Absolutely.
That makes sense. It's a reminder that math isn't just about formulas and equations.
Right.
It's also about patterns.
And relationships, yeah.
Now, I'm curious about something you mentioned earlier, modular forms.
Yeah.
You said that they have these special symmetry properties.
They do.
Can you kind of elaborate on what those are and why they're important?
Yeah, so imagine taking like a geometric shape, like a square,
Okay,
and rotating it
okay,
or reflecting it.
okay,
If the shape looks the same after these transformations, we say it has symmetry.
right.
Modular forms kind of exhibit a similar kind of symmetry, but in a more abstract mathematical space.
Oh, okay.
They remain essentially unchanged under certain transformations of the complex plane.
So it's a different kind of symmetry
It is.
than what we might normally think about.
Yeah, it's a bit more abstract.
But how does this connect to A000132?
So remember how we talked about theta series
Uh-huh.
and how the one associated with the lattice Z is related to A000132?
Yes.
It turns out that many theta series, including this one,
Okay.
possess these special symmetry properties, making them a specific type of modular form.
Oh, so by connecting A000132 to theta series, we're indirectly linking it to this whole world of modular form.
Precisely.
Wow.
And their symmetry properties.
And modular forms are really important in a lot of different areas.
They're incredibly important.
Of math and physics, you said?
From number theory and algebraic geometry to string theory and even cryptography.
It's amazing how this sequence keeps leading to these really profound mathematical
It
ideas.
really is. It highlights how interconnected mathematics is
Yeah?
and how exploring one concept can really open doors to a whole universe of related ideas.
Now, before we move on, can you give us a little more insight into why modular forms are so important?
Oh, sure, yeah.
You mentioned they appear in like string theory and cryptography.
They do. They act like a sort of mathematical bridge connecting seemingly different areas.
Okay.
For instance, a string theory which attempts to unify all the fundamental forces in the universe.
Okay.
Modular forms play a role in describing the extra spatial dimensions beyond the three we perceive.
Wow, so they help physicists make sense of these incredibly complex concepts.
They do.
And in cryptography, which deals with secure communication,
Right.
modular forms underpin certain encryption algorithms that protect our online transactions and data. So the same mathematical structures that help describe the universe are also helping us keep our information secure.
It might seem surprising, but that's the beauty of mathematics.
Right.
Abstract concepts often find applications in unexpected and practical ways.
Yeah.
And the fact that A000132, through its connection to theta series and modular forms, touches upon these diverse areas, speaks to its mathematical richness.
It's just amazing how it can start with something simple, like counting sums of squares, and then lead us to these really profound ideas.
It is. It's really fascinating.
And we're not done yet.
No, we're not.
In the next part of our deep dive, we'll explore some other connections. A000132 has to concepts like partitions,
Oh, yeah.
Ramanujan's tau function,
Right.
and even potential real-world applications. Welcome back to the final part of our deep dive into A00132. We've been talking about all sorts of things.
We have. It's been quite a journey.
It has lattices and the theta series, quadratic forms, modular forms.
Lots of forms.
Lots of forms.
It's amazing how much depth we've uncovered.
It is. And to think it all stemmed from just this sequence that tells us how many ways to write an integer as a sum of 5 squares.
It really is remarkable.
But there's still more to explore, right?
Oh, there's always more.
So the beginning you mentioned partitions.
Right.
Can you remind me how those relate to A000132?
Sure. So there's a closely related sequence, A025429, which deals with partitions of an integer into 5 non-zero squares.
Non-zero squares. Okay.
It's a subtle distinction, but it leads to a whole new set of numbers and patterns.
So A000132 lets us use 0 as one of the squares.
Exactly.
But A025429 is specifically all 5 squares have to be greater than 0.
That's right. It's like focusing our lens on a very specific subset of representations.
Okay, and are both of these sequences useful?
Oh, absolutely. Both sequences provide valuable insights into the properties of squares and how they combine, but they highlight different aspects of this combinatorial problem.
That's really interesting.
Yeah.
Speaking of interesting, you mentioned earlier Ramanujan.
Oh, yeah.
And his tau function, and you said it's somehow connected to A00132?
It is. It's a bit intricate, but essentially Ramanujan's tau function is this enigmatic function that appears in various branches of number theory, particularly in the study of, you guessed it, modular forms.
Oh, of course.
And because A000132, through its connection to the theta series of Yao and therefore to modular forms,
Right.
it also has an indirect link to this remarkable tau function.
So we see A000132, again, bridging all these different mathematical concepts.
It really does highlight how interwoven different areas of mathematics can be.
It makes you wonder what other connections are out there.
Oh, I'm sure there are many.
Yeah, but let's give gears a bit because we've been talking about the theoretical side of A000132. But a question that I think a lot of people might have is, are there any real-world applications for this?
That's a great question, and it's one that mathematicians are always thinking about.
Right.
While we might not be using A000132 directly to build bridges or design smartphones,
Right.
its theoretical connections do suggest some potential avenues for applications.
Okay, so maybe not immediately obvious, but the underlying math could be useful.
Exactly. For example, remember modular forms?
Yes.
They play a significant role in cryptography,
Right.
which is the science of secure communication.
Okay.
The fact that A000132 is linked to modular forms, even if indirectly, suggests that it might have implications for this field.
So it's possible that the insights we gain from A000132 could help make our data more secure?
It's definitely a possibility.
Wow.
And there's more Milne's work on generalizing Jacobi's identities, which are closely tied to the ideas we've been discussing, has potential implications for both cryptography and coding theory.
So even though A000132 might not be directly used in technology,
Right.
it could still have an impact.
Its theoretical connections could lead to advancements in other fields.
That's incredible.
It is. It's a testament to the power of theoretical mathematics.
Well, I think we've covered a lot of ground in this deep dive.
Yeah.
from counting sums of squares to exploring all these fascinating concepts, lattices, theta series, modular forms.
It's been quite a journey.
It really has. So as we wrap up, is there like a key takeaway that you would want our listeners to remember?
I think the most important takeaway is that mathematics is full of surprises. A sequence that starts with a simple counting problem can lead us to a web of interconnected concepts, revealing just how beautiful and elegant math can be.
Absolutely. It just shows that exploration and curiosity are so important in math, and that even in things that seem familiar, there's always more to learn.
I completely agree.
So for our listeners who want to learn more, where should they go from here?
I encourage everyone to delve deeper into the OEIS entry for A000132. There's so much information there, formulas, references, links to related sequences. It's a great starting point.
That's great advice, and who knows, maybe one of our listeners will uncover the next big connection or application.
Wouldn't that be amazing?
Well, on that note, we'll conclude our deep dive into A000132.
It's been a pleasure.
Thanks for joining us, and until next time, keep diving deep.